In today's podcast, we will be using ratio and proportion in application to geometry, specifically similar polygons. First, let's look at some vocabulary. You've already completed the matching game. Let's write it down with some examples. The first piece of vocabulary was a ratio, and a ratio was simply a comparison of two numbers. An example might be 3 to 2. Now, a ratio can actually be written in three different ways. The first way is as a fraction. The second way is with a colon. We would write that as the ratio of 3 to 2. And lastly, with the word 2. So that would be 3, 2, 2. An example in real life of this might be if you were making a frozen concentrate of orange juice, you might use 3 cans of water to 1 can of juice. So that is an example of a ratio. A proportion is a comparison of two ratios. They can be true, they can be false, or they can have an unknown value. When they have an unknown value, your job is actually to solve it and find a value that would make it be true. As an example, a true proportion would be 3 to 2 equals 6 to 4. This would be true. False would be 3 to 2 equals 8 to 4. And with an unknown, you might have 3 to 2 equals x to 4. And in this case, you have to solve it in order to make it true. Now, the process that we use for solving proportions is called cross products. What we do is we multiply the extremes and the means, and then we set them equal to each other. This is similar to what you did in your warm-up problem today. Now, I've used a couple terms here that you haven't heard. The first is the extremes. The extremes are the first and last numbers that you would write in a proportion if you were writing it in fraction form. For example, 3 to 2 equals 6 to 4. The 3 and the 4 are the extremes. 3 was the first number I wrote. 4 was the last number I wrote. The means are the two middle numbers that you would be writing. Again, the same example. We would have 3 to 2 equals 6 to 4. The means would have been the 2 and the 6. One of the good things about proportions is that the product of the means always equals the product of the extremes. For example, if you were to multiply the 2 times the 6 and the 3 times the 4, if it's true, you should get the same answer, which in this case is 12. Our next definition is similar polygons. Similar polygons are two or more polygons with the same shape but different sizes. The corresponding or matching angles are congruent and the corresponding sides are proportional. The symbol for similar is just the wavy line, looks like a tilde in Spanish, or the wavy line that goes on the top of a congruent sign, because congruent means same shape, that's the wavy line, and same size, that's the equals. The last term is scale factor, and scale factor is the ratio of the lengths of the corresponding sides in similar polygons, and that's something that we're always looking for. Now, flip to the back page, and we're going to actually solve some problems with ratios. So let's take it the first example. We have a total number of students participating in sports is 520. The total number of students is 1850, and it says find the ratio of athletes to students. So what I need to know is I need to know how many are athletes, that's 520. How many are students, that's 1,850. And then I need to simplify this fraction. Well, I can divide both numbers by 10, or shortcutting that, you can, because they both end in a 0, we can cut that off. That's essentially dividing both by 10. And my answer would be 52 to 185. Now, notice in the next problem they've changed it just a little bit. They said out of the 520 athletes, 380 are boys, and then it says find the ratios of females to males. Well, females are our girls, males are our boys. We know how many boys there are. There are 380 boys. The question is, how many are girls? So think about it for a second. Hopefully you came up with the idea of actually subtracting the total athletes and the boys, and that should give us the number of girls. So 520 minus 380 is 140. So we have 140 girls to 380 boys. Again, we need to simplify the fraction. So we're going to divide both numbers by 10, and that gives us 14 over 38. But this can be simplified as well. 2 divides into both 14 and 38, so we can simplify this to 7 over 19. So this says for every 7 girls that are athletes, there are 19 boys that are athletes. Now we're going to take this and actually apply it into a geometry problem. First off, we have some very important information. We have a ratio, and we have some information about the angles, which says they're supplementary. So the first thing you need to do is remember what supplementary angles do. And that is supplementary angles add to 180. And what it's telling me is that the angles are in the ratio of 2 to 3. That doesn't mean one angle is 2 degrees and the other is 3. It means they're in that ratio. We don't know what was divided out when it's simplified to 2 to 3. So we set up one of the angles is 2x, the other angle is 3x. If you simplified that, you would get 2 to 3. Now what do we know about these two angles? We know they add to 180. So 2x plus 3x equals 180. If you divide both, or excuse me, first we have to add our 2x and 3x together and get 5x equals 180. And then divide by 5 and get x equals 36. Now, x is not the answer to our problem. The answer to our problem is what are the measures of the angles. This is the first angle. It's not x, it's 2x. So 2 times 36 is 72 degrees. The other angle is 3x, so 3 times 36 is 108 degrees, and you can always check yourself and see if the two angles do add up to 180, which they do. Now, we're going to go to the next geometric example, which says that we have 3 angles this time, and the ratio is 2 to 3 to 4. That means one of my angles is 2x, one of my angles is 3x, and one of my angles is 4x. Now, what do I know about the angles in a triangle? Hopefully we remember they all add to 180. So therefore my equation is 2x plus 3x plus 4x equals 180. 9x equals 180. Dividing by 9, I get x equals 20. Once again, this is not the actual answer to my problem. My problem said how much is each angle, and the angles were in the ratio of 2 to 3 to 4, or 2x, 3x, and 4x. So 2x is 2 times 20, so one of my angles was 40 degrees. 3x was 3 times 20, so one of my angles was 60 degrees, and 4x for my third angle was 4 times 20, so my third angle was 80 degrees. Again, I can check and make sure that my angles all add up to 180 degrees. On our next examples, these are just examples of solving proportions. It's exactly like what we did for the warm-up. We're simply going to go through the examples and be sure you're following the process correctly. So the first thing we want to do is multiply the means and the extremes. When I multiply the extremes, I get 5x. When I multiply the means, I get 32. I know that the product of the means equals the product of the extremes, so I divide both sides by 5 and I get x equals 6.4. Now this was a fairly simple example. Let's go to one that's a little bit more complex. Remember, when you're multiplying, I'm multiplying the entire x minus 7 by the 3 and the entire x plus 6 by the 2. So I get 3 times the quantity of x minus 7 equals 2 times the quantity of x plus 6, or 3x minus 21 equals 2x plus 12. And that gives me x minus 21 by subtracting 2x on both sides equals 12. Adding 21 gives me x equals 33. In our next example, we are actually going to apply it to a scale model. Boxcar on a train has a length of 40 feet and a width of 9 feet. The scale model has a length of 16 inches. So I can set it up according to length matches with length, the same way that width matches with width. If I do it this way, the numerators of both fractions are going to be the actual boxcar, and the denominator of both fractions is going to be the model. So as I solve this problem, I get 40 feet on the actual to 16 inches on the model equals 9 feet for the width of the actual to x for the width of the model. Now I'm going to solve this, and it's important to keep your dimensions with this. So I have 40 feet times x equals 9 feet times 16 inches, or 40 feet times x equals 144 foot dash inches. We include both of those dimensions. Now to get x alone, I divide both sides by 40 feet. Here's the cool part. When I divide by 40 feet on both sides, the feet cancel with the feet, the 40 cancels with the 40, I'm left with x. On the other side, the feet cancel with the feet, and I have 144 inches over 40. Now I do need to simplify this. That would be, let's see, what divides into both of those? 4 definitely. So that would be 36 over 10 inches, or 3.6 inches. So my scale model is going to be 3.6 inches wide. This concludes this part of our podcast.